His name is Brain, actually Brian, but then apparently they messed up his birth certificate. So it was spelt Brain, and he just kind of ran with it. And he's now a doctor, so it couldn't have been that bad. And Suparna Apte, and they're talking about Python in the real world, healthcare in Africa. So Brain has a PhD from the University of Witwatersrand, and Suparna has no PhD and has only ever had reviews for restaurants published. But they both sound very interesting, and we look forward to your speech. Thank you.
Hello? Yeah.
Oh,
Uh-huh.
they kicked me out of it. I'm just gonna scream. Hi, my name. Okay. As he said, my name is Brain. Yes, Brain. And then this is my colleague Suparna. We develop software for a company called ThoughtWorks from our offices in Bloemfontein in Johannesburg. And today we're going to present to you guys how we used a little Python app to combat a really big problem in Africa and the world. And hand over to
Okay. Have you ever been sick? Who has? Nobody?
Very
Oh, we have, healthy bunch of people. Is it Cape Town weather? Yeah. Okay, so what do you normally do when you get sick? You got sick, you took your medicine, you took your rest, and it was fine, right? Everything was fine, you're back to normal, rocking. But imagine that if the medicine you took was fake, you wouldn't get better. You would make more people around you sick. But did you know that 1 in 3 medicines that are sold in Africa is fake? And they are in fact chemicals that can be life-threatening. Shocking. So, when we say fake medicals, they are not just sugar pills, right? So, there are some chemical tests that can be done to confirm the authenticity. But they are not completely reliable because these fake medicine producers are smart. They put just enough chemicals to pass the test, but not enough to fight the disease. And they are made to look exactly the same. Can you tell the difference? Which one is fake? Which one is not on the top? Anybody? No? They look exactly the same. They are often packaged and labeled similar to the real ones. But they are manufactured on the side that looks something like this. Yeah, see how unhygienic this is? The chemicals are mixed up without any medical knowledge whatsoever. And they may have harmful concentration of the drugs. So, they cause like around 100,000 deaths every year in Africa. The situation is dire.
Enter Bright and Pedigree from Ghana. They wondered how we can solve this problem using technology, and that's when we engaged ThoughtWorks. This is how we approached the problem. So first, who were our key stakeholders? Innocent people in remote areas, some of them who don't have. Better. So innocent people in remote areas, some of them who can't even tell the difference between the fake. I mean, we tried to tell the difference and we couldn't. Pharmaceutical companies who don't want their brands and names associated or tarnished by this fake medication. Who else is affected? Retailers, distributors who don't want to be part of this chain, but generally are even unaware that they are part of this chain, killing people in the community. So our approach was we wanted to ensure that the control is in the hands of the general public. Let the people on the ground level be able to have a difference between what they're taking and what is being given.
So, who knows what this is? Yeah? So, when you buy a prepaid mobile, you scratch the silvery part and then you message that code and you get the airtime, right? So on the similar lines, pharmaceutical companies would label their products with a hidden code. When you buy the medicine, you scratch off the silvery part, see the hidden code, and then enter that hidden code into our system, and we respond saying whether it's a fake product or it's a authentic one. So how do we enable people all over Africa enter these numbers into our system? Because the most affected people don't have internet access or even the habit of using internet for anything and everything like us. So the answer was mobile. So everybody has got a mobile. Even from rural areas to the cities, everybody can send and receive an SMS. So when you buy a medicine, you scratch the silvery part, send an SMS entering that code, and you get a response saying it's a fake or it's an authentic product.
So we've got an idea, and we've thought about what we want to use. We want people to use as an interface to our system. How do we go about it? The first decision was to choose a technology that would help us down that path. We had to build a showcase and as the first for our first app, and do that in a very rapid, in a very short space of time. Add to that the fact that we needed to interact with the client, get different new functionality, and rapidly integrate that and get feedback back from the client. So that required us to do some sort of continuous integration, and we needed a language that can give us the rapid prototyping capability. The other thing which we did was, because we were interacting and pushing and giving it to the client to see, and then we get feedback and all. We needed something that could handle some deployment scripts. Python came in and solved. What is a Python? That's a Python. Python came in and we thought it was the best fit for what we wanted to achieve. Add to that the fact that when we did a bit of a survey around Africa, we saw that there was a lot of Python programmers available who could maintain these systems. So there was we saw it as a long-term maintainable and possible development that can be done on this. So we've got our technology. What's the next step? We decided we're gonna send and receive. We're gonna send an SMS, send and receive an SMS. Simple as that. Vumi came in and rescued the day. And not just because we love them. That's one of the developers. We chose Vumi for this because Vumi is already an integration framework that has messaging capabilities and is integrated already with a couple of protocols, your Telnet, Telcos, GChat, and it's open source, but it's very actively supported. We had a lot of interaction with them during the startup phase, and we set up Vumi for our requirements and tested and made sure that Vumi was running how it should run. Number one, it's built for scalability, and with this application, because we were targeting a whole lot of people, scalability was going to be an issue. Number two is built around cloud environment and deployment. That answered our requirement. And number three, there's already integration in multiple territories with multiple telcos, and that's what we were targeting. So that met those three requirements. So it provided us a framework with which we could seamlessly integrate with different telcos. That's a typical simple setup. So you've got two main things that are required: transport and application workers. Your transport receives inbound and outbound messages, and the application workers processes them and responds if it has to, or does something else within the system. So we started by writing a simple log file that we receive an SMS, we log it somewhere, and then we reverse the text, and then we send it back. We send it as a response. So your typical data you'd receive would be like the sample data, where the content is what is the actual data that came in. And we did a reverse application, which it takes that message, that MSG, and then it reverses it. So let's look at some real code, if you guys don't mind. And this is thanks to some of the code we got from Vumi. So there you've got setting up the workers. So we've got a telnet client, and we've got the reverse application, which I'm going to show. So the telnet, we're just saying use a telnet on port 9003, and my application. So you've got it extends your simple application worker, which is, you can find it on the Vumi demo. It takes your content, reverses it, and then just returns it. And I'll do a telnet. That's really nicely prepared. So that's my app running, so I can put whatever I want. And all of this took us a few minutes to set up and run, integrating with the telnet. So we have now our demo system that can receive an SMS, log it, reverse test, and we wanna now do it in an environment.
Okay. So how do we choose our production environment? So if you think about our system that we are building, we need it to be up all the time. Imagine you have a sick friend late at night. You run to the pharmacy, you buy the medicine, and before you give it to your friend, you want to verify that this is authentic. You send us an SMS. You really don't want to hear, sorry, we are closed. So that was our main requirement. The first hosting decision that we took was not to try to host in-house. So onto the cloud. So we decided to host on a virtual private server because we wanted to have better control over the system. So we investigated African and global cloud providers. So the African cloud providers seemed pretty expensive for us. So our choice came down to Amazon, AWS, and then Linode. So for our specific requirements, like we needed it to be up all the time and we needed it to be cheap. So the Linode turned out to be the best value option. We set it up and we were ready to go. We could send and receive an SMS, and people all over Africa could use our system. But now when you have people all over Africa using your application, what happens? You get lots and lots and lots and lots of codes. They are going to be in billions. That's a lot of data. Specifically, fast index-based lookups and high volume of writes. As you would probably know, that traditional relational database would cringe. Does anybody know what else we could use? So this pointed to a non-relational database. So which non-relational database do we use? So with Django non-rel, MongoDB has good support with Django. So we went with that. Our next goal was to find trends. Like what part of Africa is the most affected? Nigeria? Ghana? How we could determine that? Or which products are the most fake? That one, that one, that one. We don't know, but we have a lot of data. So if we could use that data to find these trends, then it would be great. We could take some external measures like notify that area or notify the pharmaceutical company so that they can do something about it. So MapReduce queries to the rescue. So it has a map function, a reduce function, and then the output. Assume that the document in a collection looks something like this. Very simple, basic. It has a product name, code, and invalid or not. So the way MapReduce query works is that map function is called for each document in the collection. It emits a key and a dictionary. So in this particular example, the document will respond, the map function will respond with a product name which is like a key, and then a dictionary which says, okay, this invalid inquiries were there for this product. And the next step is the reduce function. So the reduce function aggregates what map function sends to it. So it takes that product name and the invalid inquiries with like array of invalid inquiries for all these documents. Then it aggregates it and says that okay, for this product name, these many invalid inquiries were there. The crucial part here that we realized only after like facing the problem, that we wrote all this. Okay, it just takes function, map function, reduce function. We wrote those. It does that. We deployed, and then we realized that oh, it is running twice. This why? Does anybody know? Okay, so what happens is if you have multiple map functions, if you want to have massive parallelization, you can have say one server running map function on 10 documents, then another for 10, another for 10, and then they all reduce that like those 10 documents to say 1, 1, 1. Then these three are run again together to reduce them to 1. So it is very crucial that this reduce function returns the key and dictionary that looks exactly the same as map function, so that it can fed into the next stage of the reduce function. So now we could have at this point we could query the code and we could find some trends. So everything was happy and rocking in the non-relational world.
But how do you know if the code that somebody has sent is valid? Whether a pharmaceutical company actually did that code, generated that code, and appended it to the system, to the box. This called for some sort of web admin interface. So you know the usual things on your typical application, your users, your roles, your approvals. We needed those as well. And we thought the Django user auth application answered that for us as a perfect fit. However, Django comes with a relational database management system. And we had already gone down the MongoDB path because of the, like she said, the non-relational database problem with the multiple codes. So we had to find a way of hacking MongoDB to work with the Django auth app, which had some sort of relations inbuilt. And after trying for a little while, it became pretty dirty, and we thought we're gonna check it out, and we use a relational database environment. And this called us to live the polyglot persistence lifestyle. Keyword, but you must look. So we had the application running with MongoDB and MySQL. The codes which were coming in, Mongo would handle, and the rest of the relational stuff, MySQL would handle. But then, how do we manage that now? What models would sit with Mongo? What models would sit on MySQL? Luckily enough, there's a Django route. Django's got what's called the router, the database router, and we're able to use that for us to tell what model should go to Mongo and what model should be handled by MySQL. But with that, with the relational came migration. So we didn't know ahead what the DBs would look like. We didn't know ahead what data would be in those DBs. So we needed some scheme that would be able to do migrations for us. Schema migration. What's schema migration? So let's say you've got a user, and initially you want to just capture the username, and eventually the system requirements change and you need to capture the email address as well. Do you go back and rewrite your system just to add that field, or do you just find a way to seamlessly make sure that from there onwards all the development environments or any environment which is going to run onto can just have that column added? That was the schema migration which we needed to do, and we identified that we're going to need to do that. Same thing with the the data migration. You've got a first name field, and all of a sudden the user decides, you've got a name field, and all of a sudden the user decides, I don't want it to be named no more. I want a first name and a last name. You already have data in your database that holds name. How do you manage the current data and make sure that you can move that data to the new DB which you want to do? That required us to do some data migration work. After investigating a whole lot of apps, or a lot of tools out there, we eventually took South as the way forward because it gave us a whole lot of benefit. But note, you should write your South migration scripts so that they can also be able to run on an empty database. Because the assumption a lot of people make is, okay, I'm going to write this migration script. This data is going to move my data and convert them to what I need it to do. But what happens in the case where you want to test your system and it's an empty database? Has anyone ever thought of that? How did you do it? Anyone? So it's important that do not just write your migration script with the assumption that you've got data always. Because it might just break when you move it to a new environment which has no data. So have that in the back of your mind. The other thing which we noted with South was the auto-generated migration scripts were creating scripts with incremental numbers. And that led to an issue where if two pairs are working on the migration script and no one has called that, hey, I'm going to be doing a migration script and pushing it across. We then generate migration scripts with the same number, and when it's trying to migrate, it's confused which of them is the right migration. So we came up with a Kleenex box as our migration token. Whoever had the Kleenex box had the right to do the migration. Not very healthy, but no one got sick. Whoever had that box did the migration, and until they handed the box over, no one was allowed to write another migration script. Someone pinched our migration box, so we came out with a migration ball.
Yeah. Has anybody used non-relational databases here? Yeah. So you faced for non-relational database, you don't really have the problems of schema migration that much because it doesn't have schema, but it does have some problems because, as he said, if you want to have like name and then you want to split that and have first name and last name, then all your previous documents which are in that collection are going to have name, and they don't have first name and last name. So there are multiple strategies. One is you just run it in the background and say before the deployment and keep the name and also duplicate first name and last name for all your previous documents, or then like whenever you load the document, like say you start storing first name and last name for new documents, all your old documents still has name, but whenever they are loaded for the first time, you change it with first name and last name and you save it back. So yeah, it doesn't really need these kind of migrations, but it had some other strategies to deal with that problem. So okay, so let's recap what we have so far. An SMS comes in, Vumi sends it to the application. The application does some processing, tracking, analysis, and then it sees if the code is valid or not. It sends it back to Vumi, and Vumi sends it back to the user using SMS. So this application started taking a long time to respond to Vumi. We quickly realized that to send a yes or no response for the code validation, we don't really need to do that analysis and tracking part. That is something different, so that can be separated. In this case, does anybody have any ideas? How can we handle this? Anybody? This is a pretty common problem. Everybody must have seen this. Nobody wants to talk? You do it in the background, right? So we use Celery for this. So now, what Vumi does is, it creates this Celery task. It says, okay, Celery, you go and do this. And then it calls the application. And then the only thing application does is checks the validity of the code and sends it back, which is blazing fast. So let's talk about Celery a bit. So Celery is a distributed asynchronous task queue, not only for Django. So what that means is, whenever you create a Celery task, one of the workers, parallel workers, are going to pick it up. And then they are going to do that task. And the distribution of tasks to the workers is handled by a message queue. So there are multiple options for message queue. Anybody use anything? Redis? RabbitMQ? Yeah, another option is just using MongoDB. So when we were comparing those, the main problem we had was number of parallel tasks. So as we have seen before, we are going to have lots and lots of code coming in, and we are going to run this task, like one task per code coming in. So when you have Redis doing it, it performs fast when you have small number of parallel tasks. But as it starts growing, Redis performance starts going down. So we decided to go with RabbitMQ, whose performance is good for high number of parallel tasks. So Celery makes asynchronous parallel processing pretty straightforward. So you instantiate it with a broker using AMQP. So AMQP is a protocol that is used by RabbitMQ. It's an open standard for all messaging middleware. Then you create a Celery task. Pretty straightforward. You just define a method and you label it as a Celery task. So all this method will do the actual ingesting, like tracking, analysis stuff, and then you start the workers. Now you need to change your Vumi code to send, like, actually call that Celery task, and then move on to calling the application without waiting for this guy to finish. So the another usage of Celery was we needed some cron jobs. For example, if you are running a map reduce query, that takes a long time. But we don't want to do those queries whenever a user requests for the trends. So we wanted to run it in the background and say, okay, run it every minute and store the results. So whenever user requests for it, you just have it ready. So even that was easy. So we just defined the Celery task as the previous one, and then you actually run the query, and you define the Celery bit schedule to say, okay, this is the task and this is the schedule every 60 seconds. That's it. So pretty straightforward.
So, we haven't covered a very important piece yet. Can anyone guess what that is? Okay. Not quite. Test. Sometimes we work the other way around, where we develop and then we test, right? Wrong. You'll hear more about that in the TDD in Python talk, Python tutorial tomorrow. But we'll just talk a little bit about tests, how it applies to our context. You want to know more about tests in Python? Tomorrow, Charles Haynes and Rachel, TDD in Python tutorial. What should be very obvious from this pyramid is unit tests are paramount whenever you write your code, because those say how each block works and that it works as it should. Then comes integration tests, that are the blocks working together as they should, and then functional. From a user's perspective, is my system doing what it should? And manual tests, we can't live without them because there's just some things which you have to manually test. But automated tests is very important. So let's start with the unit testing. We used Django nodes to find our tests, create and drop our databases, and to run the tests for us. That was already available, and we thought that gives us a whole lot of leverage. But we needed to, we thought we don't want to hit the database all the time or create objects all the time or interact so much with our system because it will slow down a lot of things. So we went for mocking, and I love mocking like the cup says. So what is mocking? It's generally confused for helpers that for the testing environment. And sometimes to make a unit work, you might need other units and environment objects that can help you to make that unit work. So mocks can allow you to create objects of a class which have the behavior and state of that class without you necessarily hitting stuff in the class or hitting the DB. So you can kind of mimic hitting the DB without necessarily hitting it. But then there's three things which generally people interchangeably think is mocking. So I'll go through them. First one, mocks, which I've just described, that keeps the behavior and the state, and we want to track how objects are in our test. Fake objects, which generally have a working implementation of what we want, but we do not necessarily want to track the state through the test. And stubs which so stubs just store information and spit it out at us. We don't care what they do after that. They just store and spit out information for us. But mocks are the only ones that allow you to verify the behavior of an object. So you want to check whether an object I created calls a method, and you want to assert that that method is called on objects. Mocks would give that to you, which the other two wouldn't.
Okay. So now let's look at some functional tests, also known as acceptance test. So the first key thing to remember when you are writing functional tests is they are slow and fragile. But they do give you end-to-end scenario testing. So they are important, but you should have, like, if you have tens of them, then you are in good shape. If you have hundreds of them, then you are in for a maintenance nightmare. So the first problem we faced, that we wanted something which will simulate running a server, because when you are running a user scenario test, you actually want to run your server, like do some or simulate that user is actually using the application, and then see if your application is responding it correctly. So live server test case provides you with that, but Django 1.3 doesn't have it. And we couldn't just upgrade to Django 1.4 because we were using Django non-rel, which doesn't support the 1.4 yet. They're working on it, but not there yet. So what we did was we just patched the live server test case into the Django 1.3. And so what is this part? This is our page model. Does anybody know what page model is? Anybody else?
Not for you.
No? Okay, so the page model is a class that encapsulates the selectors and the actions that can be performed on a particular page. So for example, this login page model will have the selectors and the actions on login screen. So we are asking the login page to log in as the admin. So this is the login page. People have used Selenium before, right? So this looks similar, so like familiar. This is Selenium. All it does is finds an element and then simulates as if the user is typing the username. So you write these methods, and all these methods chain themselves. So all these methods return itself saying, okay, so you can change them. This login method does, like, okay, go to the login page, set the username, set the password, and click login, right? And then there are two options. The login can be successful or the login can be unsuccessful. So this is a pretty basic class, but you can split this login action into two parts, saying login successful and login unsuccessful. And then the login successful returns the matrix page, which is the first page that you land on when you log in. Or the login unsuccessful method can return just the login page, because it like you are going to stay on that if the login is unsuccessful. So if you go back to the usage, you can see that we use the page that is returned by the login page and by logging in, and then we call methods on this. So the main thing to remember whenever you are using page model is that the page model should always just do the action. It should never do the assertions. So you should never have the method saying assert that you can go to latency tab. The page model should always say, okay, go to latency tab. So do what user would do if he has to go to latency tab, and let the test do the assertion saying assert that the application actually took you to the latency tab, right? So the another thing, like another advantage of using page model is that you can pull out all the functionality that is common. So for example, you can see that this matrix page is inheriting from the logged in page. So the logged in page will have all the common behavior which all the logged in pages are going to have, like showing the username, logout link. So you do that. So you don't have to keep writing all your tests. All the tests shouldn't say that, okay, now I have to get the username, do selenium.find.element by id, whatever, right? So ouch, this is not Yeah. Uh-oh. It's fine. Okay. So this is how you pull out the behavior.
So did anyone notice the functional test fixtures? Has anyone used the fixtures before? Encountered any problems with using them before? Yeah.
What
So-
were they? So what
so-
were your problems?
So when we went the functional test route and the Selenium route, we encountered such problems. So I'll just talk a bit about the fixtures. For the benefit of others, which are just seed data which you can give to your system, right? You can load them with fixtures. Now, the one thing we noted though was running the fixtures during the test. You've got the SyncDB that does a synchronization. It puts in some data into your DB already, and then you try to load your fixtures, which is data, and your DB says, "Hey, the data you're trying to load, I already have it in, probably with different keys." So there's an integrity error. You're trying to create duplicate entries, or you try to load fixtures which you've manually created because you typed them in, and you've assigned a key which probably exists in one system or another system, or you're deploying over a multiple environments. You're not guaranteed that everyone is going to have user pin key 1 everywhere you go. So we had to come up with a nifty way to. So that's your typical fixture. So you've got your private key, and we used natural keys instead of the content type keys for those who've dealt with content types before, because we noted that using the private keys of content types would change from different system to different system, and the only way not to be dependent on the primary key would be to use what is called natural keys in the Django world, which is just so you use your app name and the model, the app label and the model name, and that becomes your natural key. So to solve our problem of SyncDB to your concern, so we found out that if you run the test, for example, SyncDB runs multiple times and creates the data. So one thing you can do is you can watch out for the SyncDB signal and disconnect where it's creating your permission or whatever data it's creating, and then from there, rely on yourself to load the data. The second thing which you could do to override your primary key issue was have some sort of release task that goes and takes care of that data which you don't need. It's actually seed data, and replace that data with the right data. That was.
So we have everything. So this is our pipeline. This is what our pipeline looks like. So whenever somebody checks in the code, the first step that runs is setup environment, which, like, if you check in some extensions, new installed applications, it will do that. Then it will run the unit and integration tests, which are fast tests, and then it will use the live server test case and run the functional test. And the last part is deploy to production, which you can do by pushing a button, and behind the scenes we run the scripts to deploy to the production.
And we also use the supervisor to manage our processes in development, and we've used it both in development and in prod. It was able to manage, monitor, and restart services which we wanted to. So the aim of this project was to empower people at a grassroots level with a technologically driven tool to be able to combat counterfeit medicine, and to also be able to trust the distribution chain from the pharmaceutical companies who don't want their names to be tarnished, because the end user has received a product which has killed people, and the end user thinks is the retailer, and the retailer thinks no, the distributor might have done, the pharmacist might have done something which the distributor might have done, which the pharmaceutical company might have done. So we wanted that whole chain to be a trustworthy chain, and we saw this as a means to make sure that people can both trust the chain and trust the medication which they're getting. And the Python and the Django framework was very helpful in us achieving what we have achieved. Thank you.
Thank you, guys. Questions?
Yeah, so whenever the pharmaceutical companies generate those codes, like they use our system or they give those codes to us, we store them in MongoDB, and whenever somebody messages us, we mark we reply with good response only once, and then we just mark it used. So if somebody responds with the same code again, we just say no.
Just like to know the number of users that you've actually have catered for in the system and how it's been scaling. So has it been living up to expectations from a scalability point of view?
So right now the numbers are the system itself is about 100 people interacting with the system, but from the code point of view, we don't know how many people. It's many people. The number of codes which we are probably going to cater for is in the regions of 1 billion per year. So our systems are being designed to handle that, about 1 billion per year. Actual users, 100 to 200 users.
We're still developing it continuously.
Sorry, I have a question. When people submit the code, do they submit the product they expect it to be as well, so that you can track what the fakes are?
No, they just send the code.
The whole aim was to make it as simple as possible for someone in a remote area. You don't want them putting too much information when they submit the code. So
yeah, but if they send the same code repeatedly, we can we have that relation between product and code, so we can track that. Right? Anybody?
I think you kind of answered it by saying there's only 100 users so far, but even then, this is Africa, and I was wondering if had there been any surprising exploits, like with the mechanism you're using, it seems to be vulnerable to a man-in-the-middle attack. So have you seen that happening yet, or has there been anything else that surprised you about how people have tried to get around it?
Not yet.
Well, this actually fits in with a man-in-the-middle question. Presumably, you'll have to publish your number that people should SMS very securely. If a bad agent can get someone to use the wrong number, they can.
So we are going to have more marketing or reach out to the rural communities and trust us.
How easy have you found it dealing with the pharmaceuticals themselves? Like getting them to give you the data and work with you and stuff like that. Has that been challenging at all, or are they all very on board and stuff like that?
So we don't directly do it, but our client and pedigree, he deals with that stuff.
One more question.
He can.
I was just going to respond to that. The nice thing is that when we're doing with that, we have kind of a person in each community that can interact with the distributors and pharmaceutical companies. That starts with the trusted relationship. So actually, we kind of sit in the abstracted away position, which is really nice. Whoever's question that was.
Okay, one more question.
In which countries have you found that there's a high case of fake drugs being given out? And have you managed to detect the source of where this problem is coming from?
Not yet. Yeah,
So
well-
Ghana, Nigeria, those are the two that come from the top of my head. But also what like we said, what the aggregation which we're trying to do is to be able to present that these are the drugs that are more commonly faked, because now we'll have real data of real people SMSing into the system, of real people who are using this drug. So we'll be able to. So right now it's more based on studies and things like that, but we would have real data, real people.
Very soon.
Thank you, Brian and Suparna. Really
Thank you.
appreciate it.
So yeah, if you have more questions, you can just
You
come to
can-
the Thoughtful store.